In today's lesson, we will continue with more properties of exponents, but instead of dealing with multiplication, today we're going to deal with division. Here's just a quick review of a basic concept. You do not have to write this down. 2 divided by 2, anything divided by itself cancels out and equals 1. Same thing if you have a variable. You're still dividing the same thing by itself. They cancel out and equal 1. In this case, we have 4 divided by 2 is 2, and the y's cancel out, and it just equals 1. 2 times 1 is just 2. Now we're getting into the property. I'm going to give you some examples, and we're going to do the write it out process and simplify, and then from there you're going to realize what the property is. I have 4 to the 5th over 4 squared. If we write it all out, 4 to the 5th means 4 times 4 times 4 times 4 times 4. And then 4 squared in the denominator is 4 times 4. So now we can match up and simplify. 4 divided by 4 cancels. Here this 4 divided by 4 cancels. And we're left with 3 4s, which we can write as 4 to the 3rd power. In our second example, we have a to the 4th divided by a squared. A to the 4th is a times a times a times a. And a squared is a times a. Match up and cancel. A divided by a cancels, and this a divided by a cancels. And it leaves you with 2 a's, which is a squared. In this example, we have the coefficients 12 and 3. And you can think of that as just 12 divided by 3. And then m to the 5th, we have 5 m's being multiplied together. And in the denominator, we only have 1 m. So first, we can just do, what is 12 divided by 3? 12 divided by 3 is 4. And then match up your m's and cross off, which leaves you with 4 m's left over. So it's 4m to the 4th. So this example, 10y to the 7th over 6y squared, we have coefficients just like this last one. 10 over 6, except 10 over 6 does not divide to an integer. So instead I want you to think about reducing the fraction. And then we have 7y's on the numerator and 2y's in the denominator. Match up and cross off. Think about how would you simplify this but still keep it as an improper fraction, not a mixed number. If you cut them both in half, it's the fraction 5/3. And there are no y's left over in the denominator, but there are 1, 2, 3, 4, 5 y's left over in the numerator. So 5y to the 5th over 3. Here is our last example for this property. Same idea, but we have 2 different variables. But really all we have to do is write them out. So m to the 4th means we have 4 m's. N to the 3rd, we have 3 n's. And that's over 1m and then n squared. So match up and cross off. Here, 1m crosses off. In this case, 2 n's cross off. And we're left with m to the 1, 2, 3, m to the 3rd, and then just one single n. Let's look back at what we just did and see what we notice. Here we have the exponents 5 and 2, and my answer we have 3. Here exponents 4 and 2, final answer 2, 5 and 1, 4, 7 and 2, 5, 4 and 1, 3, 3 and 2, 1. So what is going on? All we're doing is we are subtracting our exponents. So if we have a power a to the power of m, and we're dividing by the same base a to the power of n, it's the same as if you keep that same base a and you subtract your exponents, m minus n. So when you are dividing powers with the same base, what you need to do is subtract your exponents. And there we have another property of exponents. We're going to continue with the same idea with the property we just figured out, but something different is going to happen in this case. Here we are dividing two powers with the same base, and we just learned that you can subtract your exponents. And you always do the top minus the bottom. So 4 minus 6 is -2, a to the power of -2. Let's see what happens if we were to write this out. So we have 4 a's in the numerator and 6 a's in the denominator. If you match up and cross off, you are left with nothing in the numerator, which really means you're left over with 1, and you have 2 a's in the denominator, which would be a squared. So look at how this and this relate. Second example, m squared divided by m to the 5th. Subtract your exponents. 2 minus 5 is -3, m to the power of -3. But if we write it out, m squared is m times m, and then you have 5 m's in the denominator. Match up and cross off. If everything leaves the numerator, it means you have 1 on top over. We have 3 left over, m to the 3rd power. In this example, we have the coefficients 3 over 9, and then we can subtract our exponents. 3 over 9, I want you to reduce that fraction. You can divide them both by 3, so it's 1/3, and 5 minus 7 is -2. 1/3 x to the power of -2. But instead, let's rewrite it out. So I have 3 over 9, which I'll simplify again, and then write out all my x's. 1, 2, 3, 4, 5, and then 7 in the denominator. Match up and cross off. Simplify 3 over 9 to 1/3, and then there are 2 x's left over, so it's 1 over 3x squared. Our fourth example, b to the 3rd divided by b to the 9th. If you subtract your exponents, you have b to the power of -6. And maybe you can skip the write it out and go straight to, after you subtract your exponents, we know the rule for negative exponents. It would be 1 over b to the power of 6. Okay, here's our last example. If we subtract our exponents with our x's, 2 minus 3 is -1, so x to the power of -1. But our y's, this would be 3 minus 1, which is y squared. Let's write it all out. In the numerator, I have 2 x's because of x squared, and 3 y's for y to the 3rd, all over 3 x's and 1 y. Match up and cross off. You are left with 2 y's in the numerator, which is y squared, all over 1x in the denominator. So if you look at the examples we just completed, what do you notice? We used the same idea as the property where we just subtracted our exponents, But you need to remember, what do you do when you have a negative exponent? It means 1 over, and then the positive version of that exponent. In this case, we had to bring that negative 2 to the basement, so it joined the denominator. So this is just a reminder that when you have a base to the power of a negative exponent, it means 1 over that base to its positive exponent. So there is your lesson on dividing powers with the same base. Good luck practicing this property of exponents.